So we're going to start talking about factoring today. Unit 8 is all about factoring, which is just working backwards from what you just did on your test today. So we learned how to multiply them. Now we're going to work backwards and we're going to undo them, and it's called factoring. Definitions first. Factors, okay? Factors of anything, okay, is any number or expression that can be multiplied by another number or expression to get a product. For example, if I wanted to find all the factors for 6, I would list all the things that multiply together to equal 6. For example, 1 times 6 equals 6. So does 2 times 3. So 1 and 6, 2 and 3 are all factors of 6 because they multiply together to make 6. Now, a prime number is any whole number greater than 1, so it can't be negative, and it can't be 0. So any whole number greater than 1, so starting with 2 and above, that has only 2 factors. And those 2 factors are always 1 and the number. For example, 5 is a prime number, and the reason 5 is a prime number is because the only 2 numbers you can multiply to make the number 5 are 1 times 5. So it only has 2 factors, 1 and itself. So 1 times that 5 makes that a prime number. A composite number is any whole number also greater than 1 that has more than 2 factors. For example, the number 9 is composite because it has more than 2 factors. It has the first 2, 1 times 9, but it also has 3 times 3. So 9 has more than 2 factors, makes it a composite number. So our first set of examples is we're just going to determine if these numbers are prime, composite, or neither. And then if it is composite, we're just going to name its factors. So the first one, 36. 36 is a composite number, and the reason it is composite is because it has more than 2 factors. All the factors of 36, there's 1 times 36, there's 2 times 18, there's 3 times 12, there's 4 times 9, and there is 6 times 6. Those are all the factors of 36. Clearly it has more than 2, it makes it composite. Now 61, the only 2 numbers I can think of that multiply together to make 61 are 1 times 61. There's nothing else I can come up with which makes 61 a prime number because it only has 2 factors. Now number 3, I have negative 150. If you look at my definition of prime and composite, both definitions start with any whole number greater than 1. If it is negative, it is not greater than 1. It is definitely less than 1. Therefore, this is neither because it is not greater than 1. So negative numbers are always going to be neither because they do not fall into the definition that we have for prime and composite. Now number 4, 220. Let's just start naming factors. Of course, there's the obvious. There's 1 times 220. There's going to be 2 times 110. There's going to be 4 times, oh well, gosh, we could do this all day long. But obviously it has more than 2 factors, so this is going to be a composite number. If you want to go list the rest of the factors, more power to you. I love it, okay? But it has more than 2, therefore it's composite. So greatest common factor, which is what we're talking about today, it's the big thing. And you learned how to find a greatest common factor way back in elementary school, probably 3rd or 4th grade, might have been 5th. But you did learn how to find greatest common factor, and if you are unsure as to how to find the greatest common factor of 2 numbers, we are going to do one example, but there is another video up on my YouTube wall, and it's called Mackenzie Teaches the GCF. Excuse me. And in that video, Mackenzie, my daughter Mackenzie, does 2 examples for you and shows you how to find the greatest common factor of two numbers. So if after I do it once you still aren't sure how I found the GCF, then you need to just go look up on the video and watch that video really quick. So the greatest common factor is the largest factor any two numbers have in common. And it has to be the largest one. That's why we call it the greatest common factor. So number 5, we're going to find GCF really quick. So I have 16 and 24. Most of you are going to be able to do this in your head, but just in case, I'm going to show you how to find it using factor trees. So follow along, okay? So number 16. 16 can be factored into 2 times 8 because 2 times 8 equals 16. Well, 2 is prime, so I can't factor that any further, but 8 can be factored into 4 times 2. 2 is prime, so I leave it alone, but 4 can also be factored into 2 times 2. So there is my factor tree. I'm down to all of the prime numbers. So now let's do 24. 24 can be factored into 12 times 2. 2 is prime, so I leave it alone, but 12 can be factored into 6 times 2, and 6 can be factored into 3 times 2. So now I'm just going to look at all of the prime numbers, the numbers that don't have trees underneath them, and I'm going to see which ones they have in common. Well, I see that 16 has a 2, and so does 24. 16 has another 2, and so does 24. 16 has a third 2, and so does 24. So they have 3 2's in common. So the GCF for 16 and 24 is 2 times 2 times 2, which is 8. So the greatest common factor of 16 and 24 is 8. Hopefully you were able to do that in your head, but if not, make yourself a factor tree, circle the prime factors they have in common, and then multiply them from one tree together. I didn't multiply 2 times 2 times 2 times 2 times 2 times 2. I just did the 3 of them because they have 3 in common. So number 6. Number 6 has numbers and variables. The number part is easy, okay? I've got 15, and ignore the negative. We're just going to find the greatest common factor of 15 and 20. Well, the greatest common factor, the biggest number that will go into 15 and into 20 is going to be 5. 5 goes into 15, and 5 also goes into 20. So that's my greatest common factor. You can do your factor tree if you need to, but it is the greatest common factor. Now for my variables, I have y to the third and y squared. If I write these out in expanded form, I have y times y for y to the third, and then I have y times y for y squared. Well, let's circle how many they have in common. This one has a y, and this one has a y. This one has another y, and this one has another y. So in common, they have 2 y's in common, which means that my greatest common factor for the y's is going to be y squared because they have y times y in common. Here is another way to look at it. If you will look at the variables, I have y to the third and y squared. Y squared has the smallest exponent, therefore it is the GCF. You just always pull out the variable that has the smallest exponent. So number 7. Greatest common factor, first of all, between 21 and 35. We'll do variables in a minute. The GCF for 21 and 35 is going to be 7 because that is the largest number that will go into both of those evenly. And now let's do the p's. I've got p squared and p to the first power. Well, p to the first has the smallest exponent, so I will pull out a p to the first power. Then I have a q to the first and a q squared. Well, q to the first is the smallest exponent, so I will factor out a q to the first. And that is how you find the greatest common factor. Okay, so number 8. Number 8, I have 13q to the fourth and 2p squared. I've got to find the greatest common factor. Well, 13 is prime, and so is 2. So the only thing those two numbers have in common is a 1 because they are both prime. So the greatest common factor for my numbers is 1. Now, if you will look at my variables, I've got a q and a p. They don't have any letters in common. So for number 8, the greatest common factor is 1. You can't do anything else. Greatest common factor is 1. Now, if you want to try number 9 and number 10 on your own, you can come in and ask me about those tomorrow when you get to class. But I'm going to skip down and show you how we factor using the GCF because this is the important part. This is the big deal. That's what we're trying to do. Now, if you'll remember, factors are the two numbers that multiply to equal something. For example, 2 factors of 16 are 2 times 8. When we factor this polynomial, what we are doing is breaking it up into the 2 polynomials that multiply to equal that. So I'm going to split this up, and the first thing I'm going to do is find the greatest common factor. This one has 3 numbers. You can still do the factor trees and find out what they have in common, or you can just think about it. Okay, so I have 24, 56, and 8. The greatest common factor of those 3 numbers is going to be 8. You can do your factor trees to test, but 8 will go into all 3 of those numbers, and it's the biggest one that goes into all 3. Now let's do the variables. I have an a squared, an a, and then there is no a on this one. So a cannot be part of my GCF because they don't all 3 have an a. But they do all have x's. I have x to the third, x squared, and x to the first. X to the first has the smallest exponent, so that's my GCF. So my GCF for these 3 things is 8x. Now since I'm doing factors, this times something else will equal my answer. So one of my factors is 8x. My other factor is what 8x multiplies by to equal that. So now it just becomes working backwards. I need to end up with this as my final answer. So this times something equals that. So I just got to figure out what that is. Well, 8 times 3 gives me 24. Okay, so 8 times 3 will make 24. Now I've got to fill in the variables. I have an a squared right here, but I didn't factor out any of a's at all, which means I get to keep my a squared in the parentheses. I have an x cubed in my answer, and I have already factored out one of the x's, which means in order for it to get x cubed, I need 2 x's in here, so I've got to have an x squared. Minus. Now, 8 times what gives me 56? I believe that's 7. So 8 times 7 makes 56. Now again, I have an a, but I didn't factor any out, so I get to keep my a. I have an x squared, and I have already factored out 1x, which means in order to get 2 x's in my answer, I've got to have an x right here. So when I multiply this times this, it will make that. So now minus again. Well, I have an 8x here, and I need an 8x in my answer. So 8x times what will give me 8x? Well, the only way that I can multiply something times a number and get the same thing back is to multiply it by 1. These are the 2 factors of this polynomial. If I multiply this times all of this, it will give me the polynomial I started with. And that's what we're going for. That's what we're trying to do. So let's do number 13. Greatest common factor for 35, 40, and 20. They all happen to be multiples of 5, which tells me that my greatest common factor probably is also going to be a multiple of 5, and in this case, it's going to be 5. So my greatest common factor for the numbers is 5. Now let's do the variables. I have a squared, a to the third, and a to the fourth. The smallest exponent would be the a squared, so there's my GCF. Then I have b to the third, b squared, and b squared. Smallest exponent is the b squared. And then I have c, c squared, and c. C would have the smallest exponent. This is my greatest common factor for those 3 numbers. Now my second factor is whatever this multiplies by to equal that. So 5 times 7 gives me 35. I factored out an a squared. My answer has an a squared, so I'm done with the a's. I factored out a b squared. My answer has a b to the third, so I need one more b. And then I factored out a c. My answer has a c. I'm done with this term, minus. Now 5 times 8 gives me 40. Now we'll do variables. I factored out an a squared. I need an a to the third, so that tells me I need an a here. I factored out a b squared. I need a b squared. We're done with b's. I factored out a c, but I need c squared, so I need one more c. Put your minus sign. Now 5 times 4 makes 20. Variables again. I factored out a squared. I need a to the fourth. That means I need 2 more a's because a squared and a squared makes a to the fourth. I factored out a b squared. I need a b squared. I'm done with b's. I factored out a c. I need a c. I'm done with c's. These are the 2 factors for this polynomial, because if I were to multiply this times all of this with the distributive property, this would be my answer. That is how we factor with the greatest common factor. So what I want you to do before you come to class tomorrow, I would like you to try number 12. See if you can factor it. I will toss it up as a warm-up first thing tomorrow. We will walk through it really quick together and see how you did, and then you will start your practice. I will see you guys then. Have a great day.